Hello everyone, welcome back to the Art of Engineering Efficiency Season 2. Last episode we have seen what is AI and what are internal building blocks of AI which made AI think, learn and respond same like a person. In this episode I am going to share something exciting, very personal. Honestly, a bit unbelievable for me as well. Just a few months ago, I was very much deep into building mobile applications and delivering. But suddenly something happened that whenever we see the Instagram or LinkedIn is flooded with too many posts that are saying about agentic AI, workflow integrated AI systems, NI10 and many things. So after seeing that, I thought like, what is this actually? Why are people going crazy about these things? With that spark and curiosity, took me a journey today where I ended up building a chat GPT like application running entirely on my personal laptop without any dependency on inference systems, remote systems, or registration keys, any token limitations. Purely running on my 32 GB RAM laptop and a personal desire to understand AI from inside. Let me take you through that crazy ride what I have been through. So first thing, as soon as I thought of this, because I don't have any prior experience on Python, machine learning or building agents on my own, or I have seen any. As a first step is Google it. I started exploring a bit. Then ChatGPT Copilot helped me to understand how the code looks like and what is the basic architecture of agents. With that idea in mind, I started building an agent by installing all the Python specific packages, whatever is relevant to that. I got installed in my laptop. Then I started building as the first thing a fake agent just to understand how things are connected within agent. It wasn't smart actually. Looking back, it was funny, but it worked. Then I realized, okay, now I can build agents with AI. Then curiosity doubled. It gave me enough confidence that why not build a real agent? So then I started exploring the real agents pipeline. I understood there are a few websites hosting APIs where they perform the inference with the language model that we give, but we need to get the registration keys and there are inference limit for that. So I did couple of experimentation with the SERP API and DuckDuckGo as a search interfaces and Chart Open AI as a LLM wrapper. So where we give the LLM inference host and what model we are expecting it to use for the inference. So these layers are actually helped me to understand how the agents work internally. So let's have a quick demo, see how they work. So basically, agent all is need is set of tools and an LLM and few agentic parameters. So why it need tools when I explode is tools are basically acts as a peripherals to the LLM. So LLM here core component of the agent. It will take the help of tools to fetch the data or perform few operations and use LLM to process the language content. So the agent that I created is purely supported by LangChain community and LangChain core. So the fake list LLM is part of the LangChain core. So fake list is basically which has the fake implementation of the actual LLM. The agent actually accepts the LLM object reference here. Because we need tools, I create a fake tool here and give some random explanation for this. Now we initialize this fake list LLM as a multiplication, just a hard coded value. Whatever input we give, the final answer will be 42 always. This is how the agent is initialized, and this is part of this LangChain community. Once we install the LangChain core and LangChain community, we'll be able to get access to this initialize the agent. Once the agent is initialized, we can use agent to execute any input that we can. I'm invoking it with hard-coded input, what is 7 times to 6, and the answer will be always 42 because the LLM is fake LLM. So let's try and see how it works. So we get few warnings, no need to worry about that. Those are usual warnings from the LangChain. And in the response, the output is 42. As soon as we did this invoke, it went to this LLM and got this answer as a response, and it returned as it is. If we give it here something else like 55, it's always 55 because as we hard coded, and that's how fake LLM works. So now let's jump into a real-time agent that I built to freely available online APIs like SERP API. So this is a real agent dependent on a SERP API. It's an online available tool, supported by LangChain community. Let me go to the agent initialization part so that we can actually the things in how they are actually connected. It needs a tool. So basically the tool is actually search and summarize tool or summarize tool function. And here we have a search object which actually fetches the result for a given query. So this search is again a search API, SERP API wrapper, which should be initialized with API key. So here we need to give the token. If you're trying out with the SERP API wrapper, so you need to register and get a license key. And let's go back to the initialization part. And once the search results, so the SERP API will fetch the results for the given query. Once we have the results, what it does is it calls a summarizer chain, which is a lang chain, where internally it processes the given data with the given LLM. This LLM chain is initialized with LLM. So this LLM is nothing but Chart AI reference, which is also supported by LangChain. So this chart OpenAI accepts, and we need to register an API key and give it here, and we need to give its base URL. So here I'm using a open router. Because I'm using a open router, I get an API key from open router. Similarly, if we are moving out to some other LLM API, so we can have it here like OpenAI from GPT or anything from Llama. So we can have the URL here and put the registered API key. It also has a flexibility, select which model it needs to use internally. Whatever base API URL we give here, so that internally uses this LLM and process the data. So that's how the inference works. And LLM reference within LangChain initializer and a prompt. That's what is summarizer chain, LangChain reference, and it runs the snippets. So what is snippet is the response which we got from SERP API. So they will get passed through the snippet. They will be passing it to LangChain. Once snippets are here, and the LangChain has also a reference to the prompt. So let's go and check what prompt is. Here the input variables are snippets. Whatever results we got from SERP API wrapper, so that will act as an input variable, and rest all is a prompt. So here we can clearly see, so we are instructing in this prompt that you are a search assistant summarizing news articles. We are asking it to summarize it based on a few key themed trends, positive and negative sentiments, etc., etc. So that's how the LangChain process the data which is given it with respect to the prompt. As soon as we trigger the run, agent runs the input prompt. First, it looks for the tool to fetch the data, then takes the help of LLM to summarize it or whatever is asked as per the input prompt, and it generates the output. So that's how agent handles different peripherals in the form of tools and with the help of LLM. Let's run this and see how the output looks like. So the agent is running. So here we can see few warnings from LangChain. So we can ignore that for now. It won't stop our experiment. So it is running this latest news about Vision Pro. So this is the response we got from the SERP API. Let's go with another open source API, DuckDuckGo engine as well. So this one is open, so open API, so we don't need to get any registration key. Other part remains same. We have chart OpenAI, same like SERP API engine and initialize, and I'm giving the same prompt. And let's see what would be the response. There are few warnings again from LangChain community. So here agent is processing it. Yeah, here the response is. We can actually compare both the responses because both have two different search engines. Here it has given me like in a paragraph, whereas here the description is completely briefed in different points. Here the inference system for me is openrouter.ai. Inference is completely remote, and there won't be any code execution in our local. Only the request that is sent to the inference endpoints, that's what our code does. Rest everything is handled in remote, whatever inference tool we choose, like openrouter.ai. The demo went well, everything worked seamlessly, but one thing really bothered me is we have token limits and we need to get the API key from the host to perform the inference, and altogether we are dependent on some remote host system to do our experiments, which I feel like a gray area to me, because I don't know what's happening really beneath the layers, because the host is taking care of the entire load and here I'm just hitting a request and getting the response. That's it. It's like asking a chat GPT, so I'm not getting my hands in depth to understand it in a better way. Then my curiosity doubled. Then I thought, why to depend on a remote model? Why not, if someone can build the model, why not we build the language model? I mean, that sounds really crazy to me when I tried actually after I saw the result, but I have a separate and special episode to show how crazy I went, how actually I failed to create a language model. But the experience was really good. I got my hands onto various internal components of the language model like tokenizer, transformer, feed forward, executing the loss function, and running through the multiple iteration layers, epochs. I mean, there are many other in-depth concepts that we can actually discuss. I'm going to share that in another video. After I failed to create a language model, I understood even for tech gains like Google, Meta, Microsoft, it took decades of time, and there are a lot of researchers and they spent billions of dollars to get the model running what we are actually seeing today. For me, it is highly impossible to build a language model with the resources I have with me in the current situation. With these experiences and facts, I thought it's time to move on from building a language model to running a language model which is already available in the market. So that led me to explore more of what are the available open source language models. So then I ended up at Hugging Face, where it's a repository of models, not only language model. We can find many kind of models like vision, text related, speech related, even language models. There are a lot of models and varieties of models that we can browse through them, and if something we like, we can make use of it. So every model has their own restrictions. Some models like ChatGPT's OpenAI, they require this registration keys. A few models like Mistral 7B, they give it without any restrictions, and we can use it in our local. So then I realized I can make use of Mistral 7B for my experimentation, and I went ahead with it. Then I downloaded Mistral 7B through Hugging Face in my laptop. Then using Python code, I tried to run Mistral 7B language model. But it is really a shocking experience to me that while running the model, my laptop gave up and it said, bro, no chance, I can't take more load than this. The computational power required to run this model is beyond my reach. That's what I felt when I was running Mistral 7B direct model in my personal laptop with a 32 GB RAM. Then again I got stuck at this point, looking for the solution, and again I started exploring what alternatives I have, because now we have the model, but it's a direct model, 7 billion parameter model, where it is taking huge amount of computational power from my laptop, which is not available. Then I came to know about quantized models. It actually optimizes the model in such a way that even our low-end laptops with a 32 GB RAM, 16 GB RAM, they will be able to run it. Soon after knowing that, I looked for where I can find. So I got it from the Hugging Face itself. The model is available in GGUF format, which is a quantized version of the Mistral 7B model. And we can't even run that directly. We need to have a supporting framework, which is Llama CPP. Then I cloned it from a repository of Llama CPP, build Llama CPP. After building it, then we can point our GGUF quantized model with this Llama CPP, and we can give the prompt and start experimenting. That's what I did, and it gave me the result that it actually worked like a chat GPT in my local without any inference limits, token limits, registration API keys. It's very lightweight, efficient, and powerful for the experimentation. Let's see how we can make use of Mistral 7B GGUF quantized version in our personal laptop. A complete set of instructions documented in a README file, which are available in a repository with a sample ChatGPT kind of application where you can run it in your local machine without any external dependency. Let's get into the details. First, we'll see GGUF version model download. We can't run the GGUF model directly, so that's why we have an intermediate layer which is provided by Llama CPP. So this is the system requirement which are supported by Llama CPP. Then the installation steps. Because I have already got all these things installed in my machine, so I won't be going through that explanation. I just go through various installation steps as mentioned here. First, we need to get the Hugging Face registration key or a token key. We can do the installation. Then we need to perform this login. Once we get that, then we can get a GGUF version quantized model of a Mistral 7B model from Hugging Face. This is the command for that. Then we need to clone the llama.cpp repository in our local. So that's the next step. Once the clone is done, if you are using map, you can actually go through this command list of commands. If you are using Windows, you can try with this. Once the build is done, then the model is ready to execute. This is command that will take help of Llama CPP to execute the quantized model of a Mistral 7B with a prompt text. And if we have GPU support, we can mention it. Otherwise, the command will simply ignore this line. So let's execute this command. So this is the location of quantized model in my MacBook, in my laptop. So let me give a prompt like enlighten me what is AI. Okay, so this is the prompt I'm giving it. Execute. So Llama CPP is executing it. So let's see what happens now. I'll be forwarding it if it takes too much time, if it while processing the query. So okay, it already started prompting. So this is how an LLM actually does the prompt internally. It prompts the next word one by one. Okay, so enlighten me what is AI and what is the difference between AI and machine learning. AI refers to the ability, so blah blah blah. So it started prompting word by word by having the context of what we have asked and what it generated. And so let's see the final response. I'll be forwarding a bit, and my Mac already started shouting at me with a huge noise from inside. So hope you guys too would face the same if you're trying on your laptops. You can imagine how much amount of computational power the ChatGPT, Gemini, and other online AI assistants are using. So that's why many people used to say use GPTs wisely. Even a single extra word would take a lot of computational power. That means behind that there is an energy consumption as well. You should be very conservative to choose your words and don't put vague questions or unnecessary words which will misguide the online AI assistants. Further, it consumes more power, may take more time as well. So here we got our final result. Hardly it would have like 2 to 300 words here. Total time taken by this is 168 seconds, more than 2 minutes. So that's how a local LLM works. So I hope the demo is pretty much clear. For the first time after running this, I felt like I had my own ChatGPT kind of feeling sitting inside my own machine. At this point, finally, I achieved a language model running locally in my personal laptop, no dependency on remote systems, no inference limits, unlimited experiments. So I thought let's build a fully functional ChatGPT kind of application. As a first step, I did a simple conversation kind of application with a Python code, which is giving good results. Earlier we tried with a command, but here we have a code continuously running in a loop which takes the input and throws the output. Here we have a Mistral bot, a Python script which I built similar to ChatGPT in my local. So let's go quickly and see what are the different elements of this. So here we have a model path which I have given as a GGUF model, which is located in my machine. I have a LLM initializer here. It is using Llama, which is imported from Llama CPP, where we have cloned it from a repository, and later we need to install it from Python package as well. Once we have that, we initialize the Llama and we give the model path, and the number of threads is depends on the CPU cores that your system has, and the context size. I will explain this later during the demonstration. So this is the Llama LLM initializer, and this is the key part. It's a chart method. Internally it has a while loop which is exact replica of like a chatbot. This bot we can actually integrate with the HTML website as well, just to replicate ChatGPT, because I'm not interested in building a website to demonstrate this. In this while loop we have two commands, exit or quit, so that we can exit from the chatbot. Once user input is received, we are going to construct the prompt in a structured format, because Mistral 7B is instruction based language model. The prompt should be given as instruction. If I say user input for a user keyword here, a language model understands that user has given this input and he's expecting language model to be an assistant to answer the same. That's how the prompt is formatted here. And once we have the prompt constructed, then we can call the LLM internal method with a prompt and the max token size. So the tokens, you have already aware that the user input will be divided into chunks of tokens as we discussed in the previous episode. Max tokens, you can give a number here. When to stop? As soon as it sees the assistant. So here user and assistant is the format. So when it sees the assistant, the LLM stops to generate further words or whatever it's doing currently. So it will stop there and give the response. So here is the output, and from the output, because Mistral has predefined format, this is how we parse the output from there, and this will be the final response. Let's see the Mistral bot in action. Here we can see the LLM started running. You can see a lot of logs here. So again my system will start shouting at me because I'm putting a lot of load on it. Yeah, now it's ready. So here you can see, who are you? Started the 16:16. Let's see how much time it takes. Okay, the assistant answered 24, almost took like 8 seconds. Yeah, here we can see the logs from language model as well. The total time invested is 8 seconds and evaluation time is 6 seconds, and the prompt evaluation time is this. We can actually go through these numbers for each prompt, and as we keep going the numbers may get changed based on the complexity of the prompt. Let me ask one more question. What kind of a model are you? We got the answer. So I'm a language model specifically designed to help users. It doesn't say what the model actually is. I'll say, what language model are you? Model are you? It took nearly 5 seconds and it says a large language model trained by Mistral AI. So here we can see which language model is actually running here. Let me ask a few more questions. What date is today? So far we have asked questions about the language model. Let's ask few questions on current affairs or current topics. Date and time, it is taking too much time to answer this simple question. Today's date is August 26, 2021. Its knowledge base is too much outdated. Like today I'm recording this on 20th November 2025. It's almost like 4 years old knowledge database of this language model. So we have seen how a language model can interact now. The model's knowledge base doesn't know anything that is happening recently. Then I thought, how does we can upgrade the knowledge base of this language model? Then again my search started. While doing that, I came to know that it's not that we need to rebuild the language model. There are concepts called setting the context to the language model. In addition to its knowledge base, it will also have the context. Then it will be able to answer whichever question or whatever query we ask which is related to that context. Otherwise, it will hallucinate and give some random answers, or it will simply say it is not aware of what we have asked. Let's jump in with a short demo. So in this example, I'm going to demonstrate about how we can set the context. So this is what we worked previously. So I'll uncomment a few sections of it, a few lines about myself, and I'm going to update the prompt. Here I'll say it like about me. So now I have set the context about me, and whatever question comes in, it takes the context also as a latest knowledge base and executes. Let's try now. The bot is running, model is loading. Let me ask a few questions about me. Do you know Sandeep? Let's see what it answers. Started at 29.7. Oh, finally. How much time it took? It took nearly 53 seconds to analyze the context with its knowledge base and the latest knowledge base that is being sent as a context. So let's see what it sent. It says, yes, I'm familiar with Sandeep. He's a software engineering leader with experience in, oh man. Now this is what I gave it to it as a context. So it gave an entire pair of whatever I have given here. So the same thing, let me see if it has given the copy paste. No, I don't think it did copy paste. It didn't do any copy paste. It actually got the context, literal meaning of what the para is about, and again it rewrote it from its own embeddings or wordings, and it has shared. So let me ask few more questions from here. What is now it is pretty much fast. It took nearly 10 seconds. It says like graduated from so and so college in the so and so year. Yeah, that is correct. It got the info from the context. With this working application, the language model is really working beautifully. That whatever questions we ask from the context or its knowledge base, it is crafting it very well and giving the responses. At this point, there was another problem I faced. The model wasn't remembering anything from the conversation we had. If we take a look at ChatGPT, it is able to recollect or memorize our chat conversations which we did previously, but whatever system we just built is only able to answer from the context we set from its knowledge base. So then I see there is no continuity, no memory, and no personality. Again, I got stuck with a problem. Then I went on looking for the solution. Later I realized memory is nothing but refeeding our chat conversation back to the model's context, which will act as a cognitive memory to the language model. So let's see how does setting a cognitive memory enables the continuity in the chat with the language model. Basically, a language model can't remember anything during our conversation. So we need to set back as a context our conversation, so that even if we ask anything from our past chat history, so the language model will be able to provide the output. Let's start a conversation with the language model. Removing the context here, go back to the first approach, the bot now. I'll ask few questions, and I will answer as well. And then I will ask the language model what I said previously. First, I will introduce myself as hi, I'm Kumar. The language model replied, hi Kumar, how can I help you? Now let me ask what is my name. The language model replied as, I don't have any information about my name. This is because we didn't provide the chat history as part of the context. That's why it's unable to recall what we just asked. So let's change the code. Let's change the code by setting the history, cognitive memory, and these two lines will help the language model to memorize the conversation history. So I'm running the bot now. Okay, I'll say the same thing. Hi, I'm Kumar. Nice to meet you, Kumar. How can I help you today? Let me say, I live in Bangalore. The reply from bot is about Bangalore. It's a beautiful city, Silicon Valley of India. Is there anything I need help with? Great. Let me test the cognitive memory now. I will ask, what is my name? Wonderful. Language model is able to recollect my name as Kumar from the cognitive memory. Let me ask one last question. Where do I live? The model replied, I live in Bangalore city, southern India. Is there anything else you need to know? This is a simple example of how we can enhance a language model's cognitive memory. Finally, my local language model, ChatGPT kind of application, Mistral bot, behaved like ChatGPT. It is able to remember what I said, it understood the context, and on top of that, it sounded like a real assistant. Then I realized, after doing all these things, a person like me who is having experience and entirely in a different kind of domain with a curiosity about understanding AI concepts. Finally, here I am. I had a chat GPT kind of application with a context, with a cognitive memory, and no rate limits, and zero dependency on external systems. And finally, I'm able to run in my personal laptop. At this point, I want to take a moment to say, guys, if I am able to do it, literally anyone can do it. And this is just the beginning of my journey in AI. After this attempt of building a chat GPT kind of application, Mistral bot, there was another question started bothering me. If I can run one model locally, can I run many? Can I take advantage of multiple models at the same time? Is it really possible? Can I switch between them for a different kind of actions? Maybe, for example, one model can fetch the news, identify the category of the news. The other model can actually process the input query and summarize the news and give it as an output. Can we combine their strengths and build a unified application? Is there an advanced way to manage these models, almost like having my own fleet of AIs running in my personal laptop? I went searching for the answers, and guess what? It is way powerful than what we did today. That led me to share my experience in the next episode. Something that lets you to use multiple models, customize them, and run them like a mini AI powerhouse. Trust me, you don't want to miss what's coming next. See you in the next episode. Till then, stay tuned and thank you for watching.